On the last unit, we talked about confidence intervals, and we're building confidence intervals so that we could estimate either a population proportion or a population mean. And in this unit, we're going to be doing what we call significance tests, often referred to as hypothesis tests. So you might hear me use those two names interchangeably because I'm used to using hypothesis tests, but the language in the book that we're drawing from uses significance tests. They're used interchangeably. And in a significance test or a hypothesis test, we are trying to determine the plausibility of a value being a mean or a proportion of a population. So we were trying to capture those before using an estimate those using a confidence interval, but with a test, we're trying to test out whether or not something is plausible or not. And we are always going to have two hypotheses. We are going to have what's called a null hypothesis. That's this sort of like H0, H sub 0, and then an alternative, H sub A. And they're typically going to be written in this fashion. So we have H0, HA, null, and alternative. And when we have a proportion, we're always going to be trying to test the population proportion, whether or not the population proportion could be equal to a value. Our null hypothesis is always going to be an equals to, and then some hypothesized proportion, P sub 0. Our alternative is going to be some inequality, either less than, greater than, or not equal to, and then it would be the hypothesized value. That P sub 0 is going to be a number when we actually write these. For a mean, it's going to be the mean of a population, and then the null is always going to be an equals to some hypothesized mean. And then again, we're going to have some inequality, one of them. We're going to have to pick which one based on the language being used as our alternative. And you can see there, well, actually, I don't see it here. In the vocabulary, we talk about a one-sided or two-sided alternative. A one-sided alternative is going to be less than or greater than. And a two-sided alternative is the not equal to. And more on that later when we actually run a significance test and calculate some values and do the whole thing. So here we're going to have an example, and we want to be able to write the hypotheses. And so much like in a confidence interval, I really encourage you to highlight, underline, circle important things. So here we have a hospital that's advertising an average. That means we are going to have hypotheses about a mean, and that is wait time for patients arriving in the emergency room. And then they tell us what they're advertising it as. They're saying it's 15 minutes. That is our mean 0, our hypothesized value. That's what they're saying it is. And so we want to write our hypotheses. So right there, we know it's going to be mean for both of them. The null hypothesis is always going to be equals to, and then we have that value of 15. And so now we just need to figure out what is our alternative hypothesis. And they're saying they think that it is longer. And so we're going to use a greater than alternative. Greater than meaning longer. If we said shorter, then we'd use less than. If we said something like different, then we would just use not equals to. And then we want to define what mu is. It is the mean wait time for all patients at the ER. A little shorthand there. And again, that is coming from the question, much like in a confidence interval. We can do the same thing for a proportion. Again, we have a percentage there that's telling us we're talking about P. We want to know if the result holds true. This is going to be some language that is a not equals to. And so our null hypothesis is going to be a P. Same thing with alternative. And it's that 0.14. 14% is 0.14. Because we're just asking if the result is true in a large city, we're not asking if it's more or less, then we're going to use the not equals to, two-sided. And again, 0.14. And we need to define what P is. It is the proportion of all households with children that experience food insufficiency. Sometimes when I'm writing, you can feel free to fast forward through me writing and then just pause and copy it down. And so that is how to write hypotheses. So the next thing we need to talk about is a p-value. So we have to write hypotheses, and eventually we're going to have to check some conditions like we did for confidence intervals. We're going to do some calculating, which we'll talk about in future lessons. But when we're done calculating, we're going to get what is called a p-value for a test. A p-value is simply a probability. Not so simply, it's the probability that if the null hypothesis is true, if the null hypothesis is true, it's the likelihood we would get the result from our sample just by random chance alone. And we use this phrase strong or stronger. We might say weak or weaker, more extreme. The likelihood we would get that sample value or something more extreme if the null hypothesis was true. That's a little much to take in at first, but the more you think about it, hopefully the more comfortable you can get with it. So take a pause, read through this, and then we'll talk about the elements here. So we're talking about the daily calcium intake for teenagers. We have the hypotheses here. It's a one-sided less than alternative. We're talking about average. And so if the null hypothesis is true, then the mean daily calcium intake for all teenagers will be 1,300 milligrams of calcium. So if the null hypothesis is true, that's what that means. Why would we be testing an alternative that is a less than? Well, that's because they got a sample average, a sample mean of 1,198, which is less than 1,300. So our sample mean is less than the stated 1,300 milligrams. That doesn't mean that the sample mean is, or that the hypothesized mean is wrong, but that would give us an indication that maybe it's smaller, and then we would run this significant test. So we get a p-value here of 0.1405, and so that means the probability of getting this sample mean So the probability of getting this sample mean of 1,198, if, big if, if the actual mean is 1,300, and we should say of like sample size equal 20. So it's important that we are talking about just sample size of 20 teenagers. So the probability of getting a sample mean from a sample size of 20 teenagers if the actual mean is 1,300 milligrams is 14.05%. So it's pretty small, but it's not actually super small. And then I should also say probability of getting this mean with n equals 20 or less. That's that more extreme, this or less, 1,198 milligrams or less. If you think about our normal distribution, the p-value is representing this left tail. So the probability of getting this sample value or less from 20 teenagers, if this is actually the true mean, is 14.05%. And we'll talk about how to determine if that's big enough or small enough shortly. So once we have a p-value, which we'll talk about calculating in future lessons, then we use that p-value to make a decision about the validity of our null hypothesis. And so if the p-value is small, and small is going to be relative to the problem, we'll talk more about that in the later lessons, then we would do what we say, reject the null hypothesis, and say there's convincing evidence to show or for the alternative, and we would put the context in there based on the problem, much like we did for the confidence intervals. If the p-value is not small, it's bigger, and we're going to set a benchmark, we call it a critical value for how we decide small or big. If it's bigger than that, then we would fail to reject, and this is the language we want to use. We never want to talk about accepting the null hypothesis. We just don't have enough evidence, not convincing evidence, that the alternative is true. Somebody gave me this saying not too many years ago: if the p-value is small, reject the null. And that's just kind of a rhymey way to remember what to do with the null hypothesis if the p-value is small. If the p-value is small, reject the null. And again, that is going to be dependent situationally on a critical value or a significance value that we will talk about in the next lesson. And once we either reject or fail to reject, then we can use this sort of key here to make a conclusion. We will either, if we reject the null hypothesis, we will then conclude there's convincing evidence. If we fail to reject the null hypothesis, we will conclude there's not convincing evidence. And of course, we will put the context of the problem in when we're talking about that. And we are back to our mean calcium intake here for our teenagers. We get this p-value that we talked about earlier. And I'm going to just say right off the top, that's not small relative to what normally we would consider small. And so we would fail to reject the null hypothesis. And since we're failing to reject, we would say we don't have convincing evidence. That, and then we're going to use our context, the mean daily calcium intake is less than what we said it was. So there's a lot of steps to a significance test, and we actually really just went over a bunch of them We will talk about actually calculating a p-value in the next couple lessons, and we will use these ideas of writing hypotheses, interpreting p-values, making these conclusions based on the p-value to perform full significance tests or hypothesis tests about proportions and means. Make sure, as always, if you have any questions, you let me know. Make sure you're doing all the practice and checking your answers. And as always, take your time and good luck.